So here's a quick example showing you how you can take questions like this, take facts out of them, and turn them into inequalities and even solve them. Now this video is assuming you already know how to solve linear inequalities like this one and quadratic inequalities like this one, because I've already made videos that show you how to do that. So let's get on with the question. You've got a rectangle which has height x, so I've drawn a rectangle with a height x, and its width is 30 meters more than its height, so that's just 30 more than x. So I've just drawn that, and part A says given the perimeter is less than 200 meters, make an inequality basically. So perimeter less than 200, and perimeter is basically 4x plus 60, because if you do x plus 30 plus x plus another x plus 30, you get 4x plus 60. So given the perimeter is less than 200 and the perimeter is 4x plus 60, basically means 4x plus 60 is therefore less than 200. And solving that very simple inequality gives you x is less than 35 meters. Let's go to part B. It says, given the area is greater than 1,000 meters squared, make another inequality basically. So form a quadratic inequality. Obviously it's going to be a quadratic inequality because to work out the area of this shape in algebra, using algebra, you have to do, the height times the width, so x times x plus 30, which is that, which multiplies to make x squared plus 30x, so basically a quadratic. And that this area, as it says, has to be greater than 1,000. So basically this stuff is greater than 1,000. So that's your quadratic inequality, and solving that quadratic inequality gives you two answers. X is greater than 20 and also x is less than 50, but we're not going to use that x is less than 50 because x is a length and you can't have a negative length, and besides that, it says it over here anyway, x has got to be bigger than 0. It doesn't really have to say that in a question because you're expected to realize a length has to be positive. Okay, so you've got two inequalities now. You've solved two inequalities to get two inequalities like this. X is less than 35 and x is bigger than 20. Now, by solving these inequalities, says part C, find a set of possible values of x. So I've got x is bigger than 20 and x is less than 35. Putting them together is not so hard. You can turn this round and say, well, that means x is bigger than 20 can be written as 20 is less than x, like this says over here. And if you do that, you can quite easily see that since x is bigger than 20 but it's also less than 35, basically x is between 20 and 35. Now in my previous video I kind of said that you should draw number lines and do it properly, so you can see where the inequalities overlap and then combine them properly. But it's quite easy to see without the number lines that is the solution to those two inequalities combined.